In this video, we will see how we can implement the stacks using the linked list. So let us open the program and go to the linked stack and open all these files. And stack ADT class, we have discussed it already. Then we have linked stack, and it is basically inheriting from stack ADT class. Okay, so it is a child class of stack ADT, and it must implement all of the virtual functions defined in the stack ADT class. But there is something new, and we have introduced our node type structure that we have discussed already in the previous linked list chapter. And as we can expect that it is implementing the functions from the parent. Okay, so let us see its private members. It simply has a pointer variable stack of top that will simply point to the top of the stack, top element of the stack. And as we know that linked list is a chain of nodes, so the collection of nodes. First node points to second node points to third node, and so on. So while implementing a stack using the linked list, we contain the address of the top element of the stack, right? We will have the memory address of only of the top element of the stack, and next the top element will point to the next element below it, the second node. The second node will point to the third node that is below of second node, and similarly third node will point to fourth, and so on. So we will have only the memory address of only the top element of the stack. And now let us see the implementation details. So this is basically our empty constructor. It will simply initialize stack top variable to null pointer, and then we have is empty stack function. It will check the value of stack top variable whether is equal to null pointer or not. If it is equal to null pointer, then it will return true, otherwise false. Then we have is full stack. Simply it will return false. Why it is returning false instead of checking the maximum stack size variable? Actually we do not have a maximum stack size variable here, because this is a linked list implementation. This is a linked list implementation of stack. In the arrays, we have to mention our maximum stack size, but in linked list we do not have to mention our maximum stack size, because it can be created at random memory locations in the memory. So we do not have to supply its maximum stack size. However, if we want, we can implement a maximum stack size in some other way, but for now we do not have a maximum stack size. So is full stack function will always return a false, because in this implementation style where our stack will never be full. Okay, then we have initialize stack function. It simply creates a temporary. What this function do, it will if the linked list, if the stack has any nodes in its linked list implementation, then it will remove all the nodes from the stack. How we will do this? We will simply run a loop while our stack of top does not becomes equal to null pointer. It means, as we know that stack of top points towards the top element of the stack. So when we run this loop, first the top element of the stack will be assigned to the temporary node. All right, then we will move the top element link, then we will move the stack of top to the next element in the link list. All right, the next element below of the top element. So when stack of top is moved towards the second node in the stack, then we will delete the temporary node that we have got in the first statement. So in this loop, the stack top variable will move to the next node in each iteration until it reaches the bottom of the stack, and in each iteration the element will be get in the temporary variable and then it will be deleted. So what this function do, it will simply delete all the nodes if any in there in the stack, and will initialize the stack of top equal to null pointer. Then we have push function. Let us try to understand this push function by using diagram. This is a stack at the moment. It has three nodes A, B and C. C is the top element of the stack, and our variable stack top is basically having the memory address of C. So it is pointing towards C is the top element of the stack. Now using this function push, we can pass an element of generic type, and what the function will do, first of all it will create a new node for the new element, and our new node is created, and then we will copy the new element value in the info part of the new node. All right, it means that you can see here we have created a new node pointer variable, and we have copied the new element into the info part of this new node. And then what we have done, we have done new node link equals to stack of top. Means that we are assigning the value of stack top to the link part of the new node. So let us see what it means. This is the value of stack of top. It is pointing towards C, and we have copied this value in the link section of the new node, like this link section of new node. So the stack of top is pointing towards C. Now the new node's link section is also pointing towards the new node, to the top element of the stack. Okay, so both are now stack of top and the link part of the new node, both are pointing towards the new node, the top element of the stack. And next what we have done, we have changed the value of stack top. We have assigned the address of new node to the stack top. It means that now the stack of top is pointing towards our new node. Okay, previously it was pointing to C, now the stack of top is pointing towards D. So this is basically the push function. Okay, then we have top function. Top function simply checks the value of stack top. If it is not equal to null pointer, then it returns the info part of the top element of the stack. And then we have pop. So to understand pop, we will again move to our book representation. So this is the situation before pop operation. We have three elements in the stack of top pointing towards the top element of the stack. Now as we know that the pop element removes the top element from the stack. So first of all, we need a variable or in which we will get the top element of the stack. So for this we have created a pointer variable temp, and then we have checked that stack pointer should not be equal to null pointer. If it is true, then move the top element address from stack of top to the temporary variable. All right, it means that what we have done, we have moved the value of stack of top into the temporary variable. So now both are pointing towards C. Now next, what we will do, we will get the next node in the stack using the stack top arrow link. This statement will get the next node in the stack right beneath the first node. Okay, and we will assign the memory address of the second node to the stack of top. Now what will happen, now the previously stack of top was pointing towards C, now the stack of top is pointing towards B. So it is pointing to the next node now, B. Then what we have done, we have removed the temporary uh, uh, element. So now the temporary element C will be removed from the memory, and we have got this only two elements in the stack. So this is the function of pop. Then we have again copy stack function. As we know that it receives an object of another object of stack class and copies all the elements from that other object to our new object created. And we have also a parameterized constructor that is simply calling the copy stack function to create a new object. And then we have the destructor in which we are calling initialize stack, and then we have the assignment operator overridden function that is simply using the copy stack function creating a new object. So this is basically the linked stack.